Okay, good. Come back. So if superclass does not want to share, does not want the subclass to override its method, it can put final. This is the keywords before the method name. Okay, so make sure this is the keywords final and make the underline here. Now, if it's final, then you cannot override it. Okay, make sure you cannot override it. So this is the final. Okay, so the last key points here is we have 4 access files. So one is you have already learned public, private. These 2 you have already learned. Then the third one we have protected, and the fourth one will be default. It means you don't have any access files. So today I will start with the comparison between these 4 different access files, and we will see those things. Okay, so far so good. Okay, so this one is the key points. So now we compare. Okay, we compare. So 4 access files, one is public, one is private, one is protected, and one is default. Okay, of course, public you can look at, for example, public looks like this. So public example is example. Public double, for example, get area. Okay, so you have something. So this is the public. It looks like this. So private. Okay, I can use the same. So protected. And the default is just, okay, I do like this, double get area. Right, so you don't put anything. So this is by default access files. Right, so now we look at accessibility. So we analyze the accessibility. So any method can access. So public, any method can access, no matter. So this any means inside the same class. This means the methods can be inside the same class, outside the class. So outside the class can also access. So outside the class, outside the package. So if other methods at a different package, it can also access this method. So if you declare as a public, so even so methods within the inheritance environment. So if other methods in the other class has the inheritance relationship between this method declared as a public, has this inheritance relationship, it doesn't matter, so you can access, okay? Every method can, any method can access. So for the private method, so only method within the same class can access. Okay, so private has a very, very limited accessibility. Only method within the same class can access the private, no matter data or methods. Okay, private has very limited accessibility, and the protected, so methods with, of course, within the same class can access. Okay, so this is the first. So protected is private, right? So it's the same as the private. So methods within the same class can access, but it has another one. So the methods within the inheritance relationship. So the methods within the subclass can also access. Okay, so this one means that the methods within the subclass can also access the superclass methods or data. So this one is a little bit wider than private, but it's not like public. It's open to every method. So this one is only within the subclass, which is has the inheritance relationship with this methods within the superclass. So this subclass, note that the subclass can be within the same, can be within or outside the same package. Okay, you can have another package, but you create the inheritance relationship. Then you can also access the protected area. So this one is very useful, especially when you deal with the data communication. So like the socket programming, you will see a lot of protected methods and as well as protected data, because you will have other package which has a subclass for this current package, and then they can access even they are in the different package. Okay, the default one is only methods within the package can access. Okay, so it's quite easy for default. So the default one is the methods within the package can access no matter they are in the same class or not in the same class. The only requirement is for the same package. So this one is the by default. Okay, so this is the 4 accessifiers. So public, private, protected, and the default. So some suggestions. So the general suggestion is for the data field. So you declare the field, you declare the parameters. So this one, the data field, we suggest you to use a private, okay? Use a private accessifiers. And for the method, we suggest you to use public. But some additional case is for method you may need protected if you don't want other methods you cannot control to access. So, but this is the general suggestion. Okay, for data field you use private, and for the method you use public. But some guys say that, okay, I want to access the data field. How do I do? If I want to outside to access the data field, then in your class, you will provide the public method for the other guys to access the data field. So that you can control your data field, they will not change it without any kind of checking. For this one is probably for security or safety consideration. Okay, so this one is our data field access files. Okay, now today we will do one more thing. Is the first thing. Okay, we will do polymorphism. Right, polymorphism is a kind of interesting thing. Is we can use one data type, one variable. We declare a variable to point to multiple data, multiple instance created by different class. If source class satisfy the inheritance relationship. Okay, so it's kind of interesting one. So this one is, we say that, okay, for the polymorphism, we can use one variable, one data type. So usually when you do the variable, for example, I say, okay, rectangle, a rectangle, right? So this a rectangle, a shape. So for example, I say that this is a shape. Okay, this is a shape. So previously, we can only say, okay, since this is the rectangle class, so this variable, the data type is the rectangle, so a shape can only point to rectangle, right? When you create the instance for that, it can only point to the rectangle, for example, 5.0, 4.0, right? So this is length and width. Oh, but if I have the inheritance relationship, I can also use this guy to point to square. Okay, 5.0. Okay, it's also okay. Oh, because square and the rectangle, they meet the inheritance. They satisfy the inheritance relationship. So I can use the variable with the rectangle data type to point to. Definitely, you can point to the rectangle. You can also point to anything within its, if it's a subclass of the rectangle. So in here, in this example, our square I can also use the rectangle data type variable to point to a square. Okay, so then there's one key point in this one for the polymorphism. We call it later binding or dynamic binding. So later binding is to say that, okay, if I call the method which is inherited, okay, so for example, get area. I have the get area version in rectangle. I have the square version of get area. So if I use a shape call get area, then what type of, which method I will call. So it's based on the data type declared at here. So I will call rectangle version, or I say that, okay, it's based on the instance, it's a real instance. So this one, we say that we follow the later binding. So if I declare a shape as a square, so if I do this one, if I do this one, rectangle a shape is square, and I do the a shape dot get area, then this means I will call the method, I will call get area method within the square class. This means when I compile your code, it will not check which exactly method it will call. And after you compile, when you run your code, it will see what is the actual class, actual instance it looks like. So if it's the actual is the square, it will call the square version of this method. In this example, is get area. If it's not, if it's the rectangle, if you declare as a rectangle one, then it will call the rectangle version. So this one is based on what's the real instance you create. Okay, let us see an example. So we use the rectangle. We have the rectangle version, get area, return length and width, and then I will look at the square version. Oh, square version has already inherited. So probably we will look at the toPrint version, okay? So toPrint. So in toPrint, I have one version at the rectangle. This rectangle is say this is a rectangle with certain area. And another one is in the square. It say this is the square with the area. So let us see this demo. So in our demo, I will say the rectangle. In the rectangle, I will call the square and call toPrint, okay? So I declare a square. So as the data type, maybe I will do a shape. So a shape. So I will declare the a shape to say that, okay, this is the new square. And then let us see when I run this one, you will see this is the square. Okay, to clear, I will eliminate this guy. Square version. Okay, so let us see. Okay, it will call this is the square with the area 25, right? I do. Although I declare it as in my rectangle, I declare it as a rectangle, but when you run toPrint, it will call the square version, will call the method. So this will call the method in the square class. Okay, so this one, it will be helpful. So when you create the array, so if I want to create an array for A-shape array, and then I want to have A-shape array, then what I will do is I will say that, okay, I will do shape. No. So now it will save you time. So one good example for this one, how do we use this polymorphism? For example, I want to declare an array. To say this array, I want to make sure it can store rectangle, it can store some instance from square. Then how do I declare this array? So I can declare like a rectangle array. But when I create the instance, I will tell whether it's a real rectangle or it's a real square. So it will be helpful. So you can create that one. Any question about polymorphism? Yeah, wait 2 minutes for the polymorphism. One question is, would this be good for filling objects in array list as well? Yes, this is actually, you can, for example, I do array list here. So I have the array list. So I can declare as a rectangle. Okay, so a list. Okay, so you can do like this. Oh, this one is the array list. So in the array list, you declare as a rectangle. And then when you insert into when you add to this array list, then you will declare the instance of actual class. Right, then you insert. Yeah, it's true. Any other question? So the whole thing you can do is, okay, I will do a shape. So I will declare rectangle. I can do new square, for example. And I can have a list dot add a shape. Okay, and add it into the shape rectangle class. Okay, so you should create the instance, right? So you create the instance and then add to. You cannot add a shape directly unless you create the instance for that. So far, so good. Okay, so let's move forward. Oh, this is a polymorphism. And then we will move to abstract class. So abstract class. Let's see. So what is abstract class? This is the class. The class does not want to create. Does not want to create any instance, concrete instance, but just serve, just want to just serve as the base class or superclass. It's like the superclass of certain of concrete class. Okay, so far you learned every class is called the concrete class. Concrete class means you can create, so you have already learned. Every class to now you learned is called the concrete class. So concrete class is the class can create instance. Oh, so we can do create instance. So for example, you have the rectangle class, you have the square class. You can create okay, rectangle, this is the rectangle, this is the square, so you can create the instance for this class. Today we will also introduce another class we call the abstract class. Abstract class does not want to create any concrete instance, but just serve as the superclass of some concrete class. So abstract class should be inherited by at least one concrete class. So if you do this, of course, if you abstract class can be a superclass of another abstract class, but when you go through this chain, the bottom one will be concrete class. So this one is we call abstract class. So abstract class, you can do it normally as you can code it like as normal as the concrete class. But abstract class we can have another thing associated with concrete class, abstract class we call the abstract method. This is the method. Just have the method head without body. And this method should be overridden by the concrete subclass. Okay, this one is abstract class, can have the abstract method, and this method just have the header and without any body. And this method should be overridden by the concrete subclass. And when the subclass extends the abstract class, all abstract methods should be overridden. Okay, overridden. Okay, so let us see an example to see abstract class and its application. Okay, so the first thing, how do I declare my abstract class? So the way we do is, okay, I have the public class and I will put abstract. Hey, this one will say that, okay, this is the abstract class, right, for the shape. So now our schedule will be looks like that, okay? So I will declare like that. So shape class is the superclass of rectangle, and then rectangle is the superclass of, so this is the schedule. So rectangle is the superclass of square. Okay. Okay, in the shape class, I can create a certain kind of, I can have the fields, I can have, for example, I can have the fields called the color. Okay, string color. Let's see. So let me see. So I will do this one. We'll do string color, and then I will create public. So I will create an abstract class. So this abstract class, I will call the get area. So I will use get area. Okay, so this is the abstract class. Public double. So this is the abstract class. Okay, so this is abstract class. You can have the abstract method. Of course, if you declare abstract class and without abstract methods, it's fine. So you can have your field, you can have your normal, I can have my normal method. For example, I can say public string get color. Okay, so I can get color. Okay, and return color. Okay, I can return color. And I can have my, you can also have your own, for example, I can have my constructor. It doesn't matter, public shape, or public shape. Let me see. I've got some. Oh, get area. Okay, this get area is the abstract class. So you declare, so the shape class is the superclass of rectangle. So I declare as the abstract method. So shape, actually you shape, it doesn't have any area, right? You cannot calculate any area. So, but when you create the concrete class, for example, your rectangle and or your square, you should you should declare, you should be able to calculate the area class, area method. So you will get area. So it will be overridden. It will be overridden by the others. So I will string color. So this. Not color equals to color. Okay, so this color equals to color. And I will got it. Okay, so this is the abstract class. So now let us see the rectangle class. In the rectangle class, I will override it, and I will use super. I will call color, so I will not record that here. So I will not record here anymore because this color belongs to. I don't need to get a color because it's already inside the superclass. So I will modify it a little bit. So, okay. So you will override. This one is, if you don't override the get area method, you will get an error message. So for example, so here if I don't override it, then you will see that this one you will have error at here. So it says that rectangle is the concrete class, so you should override all the abstract methods. If otherwise, another way you can declare rectangle as an abstract class, but at this time you cannot create any instance for the rectangle class. So in order to make sure this is the rectangle, so I will override, this is a concrete class, so I will override it. So in this example, if even you have the abstract class, you can declare like this. So but the question is, I can declare like this, but this one, the shape class, since I don't have toPrint method within the abstract class, so it will give me the error message. So in order to accommodate with this guy, I will create another abstract method. It's called toPrint.